today's lesson is on word problems, Part2, because we are now going to be looking at word problems that lead to quadratic equations for us to solve. So the first example says, when you multiply Jane's birth date, which is just the number of the day in the month, so not the whole thing, by the day after she was born, the result is 56. On what day does Jane celebrate her birthday? So let's do this. I want to have some more space. All right, there we go. So we need to first have our let statements. That doesn't change. We always need to have something. So we're going to say let, I'm going to use D. So let D equal Jane's birth date. And now they have told us that this date times the day after. So the day after would just be D plus 1. Gives me 56. And now we need to solve. So remember, the zero factor rule talks about when two things multiply to give me 0. That's not what I have here. So I cannot just start solving for D. I have to put this into standard form. Okay. So we want standard form. Or I'm going to write here, put it in standard form. And so remember, standard form, in case you've forgotten already, looks like that. ax squared plus bx plus c equals 0. So when I do that, we're going to multiply, and I'm also just going to subtract the 56 at the same time. So everything now equals 0. And now we have a quadratic in standard form. So I'm going to factor now. So I'll write the next step here. So that was the first one. The next one is factor. Because now I can use my zero factor rule because it's equaling 0. Don't forget the equals 0. Some of you, when you were doing your quadratic equation work, you would forget that equals 0. You drop it. Don't drop it. Okay. And so I need two numbers that multiply to give me negative 56 and add up to 1. Because remember, in front of this is a 1. I'm going to put my X puzzle here just in case you need it. So we want to multiply to negative 56. And we want to add up to positive 1. And those two numbers are 8 and negative 7. So when I do that, I'm going to get D plus 8 and D minus 7. This tells me that D equals negative 8 or D equals 7. Now remember when we were doing quadratic equations where the numbers don't represent anything, right? They're just numbers. X doesn't represent anything. It's just X. Here, D represents something. D represents the day in a month. Okay, so there's actually a condition now because this answer is actually not applicable. So we're going to write here NA. It means not applicable. Okay, you don't not write it. The equation leads us to two answers. One of them gets rejected. You can write reject, but I just feel like it's a bit harsh. So we put NA. It's not applicable. Okay, and therefore Jane, or Jane's birthday, you could say, is on the 7th. Okay, now we are going to do another one. So a local stationery store is having a competition to win a new pencil box. The entrants need to determine the dimensions of the lid of the box. They are told the lid has an area of 50 square centimeters and the length is 5 centimeters more than the width. So a lot of words here. We want to know the dimensions of the box. We are given the length in terms of the width. So I'm going to say let W equal the width. And I actually want my let statement to be in pink. Okay, so let W equal the width. That would mean that the length, and they say the length is 5 centimeters more, so W plus 5. We are told the area. Area is length times width. So when I multiply both, I'm going to get 50. We are in the same scenario that we had earlier where we're multiplying, but we're multiplying and we don't get 0. So that means we have to expand and put it in standard form. So when I expand this and put it in standard form, that's what I'm going to get. Don't forget your equal 0. Now we have a quadratic that we want to solve. So we want two numbers that multiply to negative 50 and add up to positive 5. And those numbers are positive 10 and negative 5. So we're going to have two brackets. Don't forget your equal 0. W plus 10, W minus 5. When we solve that, we get W equals negative 10 or W equals 5. Now again, we are talking about dimensions. Now in the previous section where we're just doing equations, then the numbers don't represent anything. Here, the numbers represent the length or the width. They represent dimensions. So you can't have a negative measurement, okay? So this value, we write it out because it is a valid solution to our equation, but it is not an applicable solution. So we write NA, and then we have our therefore statement. The width is 5 centimeters. Don't forget your units. And the length is 10 centimeters. Okay, so just to remind you again that when we have a situation where two things are multiplying but they don't equal 0, we can't use the 0 factor rule. It doesn't exist, okay? We have to expand, put it in standard form, factor, and then solve. And then whenever we get our two answers, we always have to pay attention to what are we talking about. If we're talking about things like time and distance and measurement and days, those things can't get negative answers. They also can't get fraction answers, right? We can't have a fraction day, okay? Or day of the month. So that's important to think about. So when you have your two answers, always look at the context. Okay, so what does this number represent? And then decide whether you have both answers valid or whether one of them is not applicable. Another thing to remember is that only happens when you are given context. So in our previous section, we never had a scenario where we wrote not applicable. And that's because in the previous section, the numbers didn't represent anything. So there was no condition attached to it that could then render a solution not applicable. Okay, so that's important to think about. All right, so make sure you take this down, make sure you have all your notes and anything that I've been talking about that you want to just jot down to remind yourself, make sure you have that there too.